Hello everyone, this is the walkthrough videos for week 5, problem 5.3. This is a counting problem, and this problem may be a little hard because it's from Amy, but if you really understand it and go with me to walk through this problem, it will be really helpful for you to understand accounting. We have 6 cards, numbered 1 through 6, which are lined up in a row. Find the number of arrangements of the 6 cards of these 6 cards where one of the cards can be removed, leaving the remaining 5 cards in either ascending or descending order. The first thing we need to notice is the ascending or descending order. If we think about a list, for example, 1, 2, 3, 4, 5, 6. For this arrangement, if you read from left to right, it's ascending. But if you read from right to left, it is descending. So this essentially tells us about the symmetry. Whenever you have an ascending order, you can just flip the order of this array and you can get a descending order. So which means that we can only consider one case, which is the ascending case. And then at last we can just times 2 by symmetry. So right now we only have to deal with the number of arrangements with ascending order. But this still could be a little bit hard. So we need to start with our base case. In the question, it asks that we can remove one of the card, and we only need the remaining 5 cards to be ascending. If that's the case, we can first pick the card to be removed, which have 6 possibilities. And if you think that if you just remove a card, then automatically the arrangement for the arrangement of the last 5 cards, that arrangement is determined. For example, if I remove, let's say 4, so what I left is 1, 2, 3, 5, 6, because all of them are different. So the only order you can make it an ascending array is 1, 2, 3, 5, 6. So the only thing that can change this arrangement is by placing this 4. For example, you can place it before the 1, or between 1 and 2, or between 2 and 3, blah, blah, blah. And you have 6 possible places to place this 4. So times another 6. So the first 6 is by the card, and the second 6 is by placement. So that gives us the base case of the ascending order, which is 36. But one thing you may notice is that we are actually overcounting the number of array. So we need to use some edge case and delay that edge case. For example, if we think of 1, 2, 3, 4, 5, 6. Because this arrangement is already in ascending order, so you can just delete any of the card and it will still be an ascending order. For example, we can delete the 1, 2, 3, 4, 5, 6 is ascending, or let's say we can delete the 4 and 1, 2, 3, 5, 6 is ascending. So we are actually counting this arrangement 6 times, which means that we have to minus 5. And the other thing you may notice is some edge case about the adjacent numbers. For example, in case 1, 2, 4, 3, 5, 6. Because 3 and 4, they are adjacent, so you can delete the 4, make it 1, 2, 3, 5, 6. It is ascending. Or we can delete the 3, make it 1, 2, 4, 5, 6, which is also ascending. So we are also overcounting those adjacent cases, or let's say consecutive digits. So in this case, we need to think of how many consecutive digits can we get. We can get 5 pairs because we have 6 numbers. So we need to minus another 5 for the consecutive digits. So right now we have to deal with all of the base case and edge case, so we can come up with our final answer. Our base case is 36. We minus 5 by the first edge case, minus 5 by the second edge case, and then times 2 by symmetry, which gives us our final answer, which is 52. So this question is a really useful example to show you how the counting works. First, you can think of whether we can simplify the question by symmetry. And then we deal with base case. The base case should be simple, like 6.6. This one is not that hard. Of course, this approach is not perfect if we overcount things, but we want to make our base case just intuitive, simple. Then we can just deal with it. And then when it comes to edge case, we have to really carefully think about whether we are doing wrong with some edge cases and to solve it. And this is how we get our answer, 52. Yeah, that's it.